To troubleshoot a neutral problem in a 208 volts 3-phase Y system, firstly, verify the neutral ground. Ensure that the neutral is properly grounded at the center of the Y connection. It needs to be a solid connection with low resistance. Secondly, check the wiring to the power supply. Trace the wiring from the neutral terminal of the transformer to the power supply, and make sure there are no loose connections or breaks in the wire. Thirdly, measure the resistance using a multimeter. Measure the resistance between the neutral terminal of the power supply and the grounded neutral. The resistance should be close to 0 ohms. Fourthly, check for an unbalanced load. If the power supply has an internal resistance, an unbalanced load can cause the neutral voltage to drop. Verify that the load is evenly distributed across all 3 phases. Fifthly, consider using a neutral booster if the other troubleshooting steps do not resolve the issue. This device can inject additional current into the neutral to compensate for the resistance in the power supply. Sixthly, isolate the power supply. Disconnect the power supply with the neutral problem from the system. If the neutral voltage problem disappears, then the power supply is faulty and needs to be repaired or replaced. Seventhly, check the transformer connections. Verify that the transformer is connected in a delta Y configuration with a high lag. Incorrect transformer connections can cause neutral voltage issues. Finally, if unable to resolve the issue, consult a qualified electrician to inspect the system and diagnose the problem. As additional tips, one should use a quality multimeter with high accuracy to measure voltage and resistance. Ensure that all electrical connections are tight and secure. Avoid using excessive load on the power supply, especially if it has a high internal resistance. When dealing with electrical systems, always prioritize safety. Wear appropriate personal protective equipment such as safety glasses and insulated gloves. Ensure that the power is disconnected before working on any electrical connections. If the power supply has an internal resistance, it can cause a voltage drop on the neutral conductor. This can result in a lower voltage reading between one phase and neutral compared to the other phases. If the load is not evenly distributed across all 3 phases, it can also cause a voltage imbalance on the neutral conductor. An unbalanced load means that one or more phases are carrying more current than the others. This can create a voltage difference between the neutral and ground, which can affect the performance of sensitive electronic equipment. A neutral booster can inject additional current into the neutral conductor to compensate for the voltage drop caused by internal resistance or unbalanced loads. This can help to restore the voltage balance on the neutral conductor and improve the performance of the system. However, it is important to note that a neutral booster is not a substitute for proper grounding and wiring practices. If the neutral is not properly grounded or the wiring is faulty, a neutral booster may not be able to correct the problem. Before connecting any equipment to the system, it is important to verify the voltage and polarity of the conductors. Use a multimeter to measure the voltage between each phase and neutral, as well as between neutral and ground. Make sure that the voltage readings are within the specified range for the equipment. Also, verify that the polarity of the conductors is correct. Connecting equipment with the wrong polarity can damage the equipment or create a safety hazard. When troubleshooting electrical problems, it is important to follow a systematic approach. Start by identifying the symptoms of the problem, such as low voltage or voltage imbalance. Then use a multimeter to measure the voltage and resistance of the conductors. Compare the readings to the expected values to identify any faults. Once you have identified the fault, you can take corrective action to repair the problem. If you are not comfortable working with electrical systems, it is best to consult a qualified electrician. An electrician has the training and experience to safely diagnose and repair electrical problems. They can also ensure that the system is properly grounded and wired to meet all applicable codes and standards. Remember that electricity can be dangerous. Always take precautions to protect yourself from electrical shock. Wear appropriate personal protective equipment and disconnect the power before working on any electrical connections. If you are unsure about any aspect of the work, consult a qualified electrician. Here's a more detailed breakdown of each troubleshooting step. Firstly, verifying the neutral ground is paramount. This ensures a low impedance path for fault current to return to the source, facilitating the operation of overcurrent protection devices like circuit breakers or fuses. The grounding electrode conductor, typically connected to a grounding rod or water pipe, should be sized according to the National Electrical Code, NEC, Table 250.66, based on the size of the service entrance conductors. The resistance to ground should be 25 ohms or less, as specified in NEC section 250.53. If the resistance exceeds 25 ohms, an additional grounding electrode is required. Secondly, checking the wiring to the power supply involves a thorough visual inspection. Look for loose connections, corroded terminals, or damaged insulation. Use a wire tracer to confirm the continuity of the neutral conductor from the transformer to the power supply. Pay close attention to the terminal connections, ensuring they are properly tightened and torqued to the manufacturer's specifications. A loose connection can create a high resistance point, leading to voltage drop and potential overheating. Thirdly, measuring the resistance between the neutral terminal of the power supply and the grounded neutral should ideally show a very low resistance, close to 0 ohms. A higher resistance indicates a potential problem in the neutral path. Use a high-quality multimeter with a low ohms range for accurate measurement. If the resistance is significantly higher than expected, investigate the wiring and connections along the neutral path to identify the source of the resistance. Fourthly, checking for an unbalanced load is crucial in three-phase systems. An unbalanced load occurs when the current draw on each phase is significantly different. This can cause a voltage imbalance on the neutral conductor and lead to overheating. Use an ammeter to measure the current on each phase. The current should be balanced within a certain percentage, typically 10% to 20%. If the load is unbalanced, redistribute the loads to achieve a more balanced current distribution. Fifthly, the use of a neutral booster should be considered as a last resort. A neutral booster is a device that injects current into the neutral conductor to compensate for voltage drop. It is typically used in situations where the neutral conductor is undersized or the load is highly unbalanced. Before installing a neutral booster, consult with a qualified electrician to ensure that it is properly sized and installed according to the NEC. Sixthly, isolating the power supply with the neutral problem helps determine if the issue is internal to the power supply or external. Disconnecting the power supply removes it from the circuit, allowing you to measure the neutral voltage without the influence of the power supply's internal components. If the neutral voltage returns to normal after disconnecting the power supply, it indicates that the power supply is the source of the problem. Seventhly, verifying the transformer connections is essential to ensure proper operation of the system. A delta Y transformer provides a grounded neutral point, which is necessary for single-phase loads. Incorrect connections can lead to voltage imbalances and equipment damage. Use a phase rotation meter to verify the phase sequence of the transformer. Also, check the transformer's nameplate to confirm the voltage and current ratings. Finally, consulting a qualified electrician is always recommended if you are not comfortable working with electrical systems or if you are unable to resolve the problem. An electrician has the training and experience to safely diagnose and repair electrical problems. They can also ensure that the system is properly grounded and wired to meet all applicable codes and standards. Remember to always prioritize safety when working with electrical systems. Wear appropriate personal protective equipment and disconnect the power before working on any electrical connections. If you are unsure about any aspect of the work, consult a qualified electrician. Here's a deeper dive into specific aspects. Firstly, concerning verifying the neutral ground. The ground connection should adhere to NEC Article 250, which provides comprehensive guidelines for grounding and bonding electrical systems. The grounding electrode conductor connecting the neutral to the grounding electrode must be sized appropriately, typically based on the size of the service entrance conductors, as per NEC Table 250.66. The grounding electrode itself can be a ground rod, a metal underground water pipe, or a concrete encased electrode used for ground. The resistance of the grounding electrode system should be verified using a ground resistance tester, and ideally, it should be 25 ohms or less, although low resistance is always preferable. Secondly, in checking the wiring to the power supply, pay attention to the wire gauge, which should be appropriate for the current carrying capacity as specified in NEC Table 310.16. Loose connections can be identified by visual inspection or by using a thermal camera to detect hotspots. Damaged insulation can be a sign of overheating or physical damage, and the affected wiring should be replaced immediately. Consider performing a voltage drop test on the neutral conductor under load to identify any excessive voltage drop, which could indicate a wiring problem. Thirdly, when measuring resistance, use a digital multimeter with a low resistance range and good accuracy. Before taking the measurement, ensure that the power is completely disconnected from the circuit to avoid damaging the multimeter or obtaining inaccurate readings. If the resistance between the neutral terminal and the grounded neutral is higher than expected, check the continuity of the neutral conductor using the multimeter's continuity testing function. Fourthly, with checking for an unbalanced load, the current imbalance should be calculated as a percentage of the average current. For example, if the currents in the three phases are 20 amps, 22 amps, and 18 amps, the average current is 20 amps. The imbalance is calculated as the maximum deviation from the average divided by the average, which in this case is 22 amps 20 amps/20 amps equals 10%. A high current imbalance can lead to overheating of the transformer and other electrical components. Fifthly, consider the specific characteristics of the neutral booster. Neutral boosters typically use autotransformers to inject current into the neutral conductor. The size of the neutral booster should be carefully selected based on the amount of current imbalance and the voltage drop on the neutral conductor. Ensure that the neutral booster is properly grounded and protected by overcurrent protection devices. Sixthly, isolating the power supply allows you to perform further testing on the power supply itself. Use a multimeter to check the input and output voltages of the power supply. Also, check the internal components of the power supply for any signs of damage or overheating. If the power supply is faulty, it should be repaired or replaced. Seventhly, the delta Y transformer configuration provides a grounded neutral point, which is essential for supplying single-phase loads. The high leg, also known as the stinger leg or weld leg, is typically 1.732 times the voltage of the other two phases to neutral voltages. Verify that the high leg is properly identified and labeled to prevent accidental connection of equipment to the wrong voltage. Finally, a qualified electrician can perform a comprehensive inspection of the electrical system and identify any potential problems. They can also provide recommendations for improving the safety and reliability of the system.